Awesome. All right. Hello. My name is CJ, and I'm a developer relations engineer at Google. And today I'm going to be talking about indemnity. So that's the first thing. Very easy. So the fact that makes it possible that my president is why is that James to be to cover the file and go over okay? I'm going to do data layer recap, the balance, talk about how that works in it. I kind of leave it is a way of what the function and data and I'm going to talk about offline first data access, synchronization, and conflicts. And then the really fun part is I'm going to talk about how we do this IRL. So, with that said, let's do a little recap of the data. Now, currently, we have recently launched some revamp architecture guide on and then we talk about the data layer, and data layer is pretty much two things. It's data sources and repositories that manage it. And then the repository is responsible for exposing data, centralizing changes, resolving conflict with business logic. Also really, those words actually, it's what we try to address this. If you want to recap with this, you should check out that short link. It's the MAD master for supporting Android development. And also, I have to find out some of it, so every time I say that, the modern Android architecture guide will go over this and all the details. Okay, with that said, what is Idemnity? Well, Idemnity is protection as well. So imagine you have a car, you have a home, you have an insurance policy, incidents. You actually identify yourself amongst the insect. Tonight's work with the Latin group from Dennis and Percy from multi-credit, later becomes identified. But then again, I bet you all want to be like, okay, data layer, identify. Well, what could you possibly try to identify yourself against in the data layer? I'll tell you. You can use internet access. So this talk is really an offline first talk. Just talking about offline first thing with Android. Now, what is an Android first app? And I think this is an interesting question because when I was writing the guide, it's not published yet, but hopefully it will be soon as I was making this talk. I actually just Googled it, like what does the internet say offline first is? And what you find out is that there's a lot of companies, whether it's a platform as a service or service as a service, whatever kind of company, they'll just say offline first, and then they'll define it with their product, and then because it's really get to actually use their own thing. Such a thing. You come with great conference just so they can tell you about the stuff that makes companies good. I know my first stop is an app that works without the internet. That is, it can perform some or all of its business logic offline. That is fundamentally what an offline first app is. Now, why should you do this? Or why should you that? Well, it turns out that your app will be temporarily offline. You can tunnel, you can fly. You have limited extra bandwidth, you can be using devices with occasional internet access, for example, like a Wi-Fi only tablet, that sort of thing. Or something that just kind of connectivity for whatever reason. So a couple of great examples of this is if you had a to-do app and you were going through a tunnel and you wanted to see what tasks are behind, you could start to see the tasks apply. You can use a Spotify or any app like that, even if you had no internet access, you should still expect to be using use. So these are a few reasons why you want to consider an offline first app. So, with that said, based on set, how do you go about designing an offline first app? Well, we already said that the data layer is very much comprised of repositories and all the data sources that you need. So it kind of stands to reason that an offline first app, you would have at least fundamentally have a local data source so you can actually read data by that. In addition to your local data source, you probably also want a network data source to augment it and feed it for the cases when you are online. Okay. Now, that was already established that you have a local and a network data source. How do you actually model data with this sort of thing? Well, it turns out your local data and your network data oftentimes are very semantically different. So because they're semantically different, it sort of helps kind of be separate models for your local data and your network data. Now, this may seem like a lot of hassle, it may seem like it's not necessarily worthwhile, but as you start scaling out, the benefits kind of show themselves. And then when you actually do this, you kind of put the models in different packages, and then if you're feeling like going them out, and like to make a lot of weird references here and there. I like Hercules, the movie. Like he was discovering himself, he was like, I can go. I'm paraphrasing now, but I'm projecting anymore. But you know, to go the distance, you can expose a third model to kind of like, insulate your other layers from things that are particular to the network and your local data sources. So again, this is all available in the Android app. And this is what I structure for package structure in Android looks like. For example, we have the local database we use for so we say entity suffix, we have the author entity, we use the non-Android database or network, we have the Android network author, and then these are kept internal and they actually expose just the author type. Now, what does this really look like? So in Android, the author entity, notice there's a bunch of gobbledygook and room annotations to make sure that this is actually representing like the local data track of SQLite. For network, there's the serializable annotation because we use combination serialization because it's serialized. But usually, the author that the rest of the app sees has nothing, no declarations, it's just a plain data class. They don't care how it's presented, they just want to read the author. Now, in this case, it seems really similar, almost trivial, that just kind of declare the same three things in three different places. But you go through the source, and now Android, for news resources, for example, every news resource that's shown in Android has an author in it. And whenever you want to display a news resource and the author, you kind of want the author's name, you want the top bunch of, you want the author's profile picture. It's a bunch of metadata that is associated to an author. If you go back to the network author, if you look at the network news resource now in Android, it won't be easy when you fetch it from the network, it just gives you the author ID. The API response does not give you any other metadata about the author. It doesn't give you the name, doesn't give you the profile picture, it gives you none of that, just their ID. So in our Android, the actual local, the version of the news resource that we expose, actually has all that data populated because we fetch that from the database. So this is another good reason why it's probably worthwhile to invest in certain things into local, remote, and only exposed. Because the way you fetch data from the network, most likely it's in the way you want to actually display in your app. Okay, so now because you've got this three representations, you kind of typically want to map back and forth between them. Now in Android, the way you did it is for every network resource you have an as entity, which converts it to an author entity because the pull from the network persists straight to the database. Nothing you pull from the network ever goes straight to the other layers that they have. And just hit it, fetch it from the network, and write it straight to the database. Then you pull from the database, convert it to the external model that the rest of the app to use. Okay. So talk about modeling, let's talk about data access. What are the things you do in your data layer? You typically want to do things. Typically read data or you write data. So let's talk into offline first reads. The first thing you do when you're trying to read data in offline first app is, so reads in any offline first app are fundamental operation you're performing in data, right? So at the very least, you should be able to read or listen to a user online. Now, you typically want to do this with observable data types. The reason you want to do this is because in between network connectivity, data can change out from the meeting. So imagine that you're looking at some data, you make a network request, you have data changes. So typically we use observable types so you can actually notify your consumers or your readers that data has changed. Because of this, data will change online and offline. There are a couple of strategies you may want to consider for structuring reads in your apps. So, I actually kind of like this track quite a bit because it's one of those things that's like people say, oh, it starts at, hey, this is all you have to do, and it's like, hey, it's really, and it's like, oh, well, it's a bit more. But first, when you want to like structure your read or offline first app, again, it's how to do it in Android. You queue read till the network is available. And then you kind of monitor the network. It's like, oh, we actually have internet connection. Now we're going to perform a read, we're going to update our local data source, and then we're done. Easy, easy, when this weird quite nice. But it turns out it's never really quite that easy. Because you attempt to read from the network data source, and assuming everything goes as well as you would like, you just your E6, you update the network, you update the local data source, at which point you're done. Now, if this part doesn't happen the way you want it to, and your read fails, the next step you do is, well, should I try again? If you shouldn't try again, then you're done. Everything is local. If you should try, kind of like create this loop, and then that text read from the network data source, and then kind of repeat it over and over again. If you keep failing, you typically want to use exponential backup. In other words, you try to read 30 seconds later, next time a minute, next time 2 minutes, next time 5 minutes, and keep backing up to you succeed. Well, typically goes in this kind of like cyclical. In Android, this is an excerpt from the offline first topic repository. So when you actually want to read data from the repository, we actually read directly from the DAO, so we read directly from the database, we expose it as a stream, and then that's what we use the external mapping. Maybe say, TJ, I don't stand the exponential backup stuff for this code snippet, which I said, yes. You don't. I'll get back into that in a bit, but there's a reason you actually sit in the snippet. But fundamentally, the read operations from repositories and offline first are fundamental things, and because it's so fundamental, you should always read directly from the local data source. There's no you shouldn't try to read from the network and then try to follow it. The rest of the app. Just keep your local database as a source of truth. Alright, so that's it for reads. Let's talk about writes. Now, common or the safe knowledge at this point is that when you're trying to write data, you should use synchronization with this coroutines, Java, or what have you, so you don't know what you might write. But for offline first apps, you should also do this because he kind of lets you, apart from walking you record, kind of lets you, to make all the decisions as you try to read, kind of like users where you read it, write the data, and then lets you make practical decisions. But more crucially, because you have two data sources you're trying to manage in multiple network, you may have some conflicts that you need to resolve. That's going to be a recurring theme. I'm not going to go too much into in this section. I will answer other sections, but that's kind of like a recurring theme. So we talked about read strategy. Let's talk about some write strategies. Again, very nice, simple diagram. First, you start. You first update your local data source, and then you include the write to monitor the network when you're online, kind of write across the remote boundary. After you write it across the remote boundary, you then prompt it to handle that, and then you're done. That's easy. But much like other things, where it's that easy, almost never is quite that easy. So again, try to write over the network, and then if you succeed with your write, your local data source. Again, depending on how you model it, sometimes you actually just want to write to your local data source before you write across the network. Sometimes you write across the network versus to your local data source, kind of depends on the requirements that you have. But if this all works out, then if this doesn't work out, well, you don't just do something. You just throw an exception and let the user know. And like, that's it. Try to write data. That's it. I think the typical thing is like, there's an error, try to fulfill your request. The copywriters and PMs are really good at this. Which, incidentally, is one of my favorite things. Like your PM just says, they just do this copy update, and then if you're doing if you guys work in a sprint, and then it's one of my favorite tasks to drag into the sprint. It's copy data task. You're going to go here for the copy change. But there's a couple of skeptics amongst you. Some of you see that the session is like, my data is important. My user tries to write something persist that. Which I say, you're absolutely right. I can do better than this. And then they kind of go through this loop again, and then should I retry, and then if I don't retry, and then you guys do the same back up. And again, what skeptics amongst you? They're like saying to me, like, hey, TJ, you just repurposed 2 diagrams. This looks exactly like the section. Which I say, yes, I did. For a good reason, for a really good reason. Again, this is typically how you do it, right? Again, and now in Android, you have a proto. So NIA Professor's DataStore is it's a proto DataStore from the DataStore API. And then you notice again when I'm writing stuff here, I just call the data source and I set proto topics. Again, if there's anything that I can mention back up, you don't see anything about user, very good reason. I'll show you why in a bit. But the important thing is writing data in an offline first app often requires a bit more consideration than reading because there might be conflicts. All right. we're going to talk it. There's more. We're going to talk about synchronous topics now, and this is kind of really interesting, right? Because again, you have two kinds of data sources. You have the local, you have the network, and then you kind of have to make sure that it's sync. Sometimes you could write to the local data source, or you write to the network has to catch up. Or some else might bring something to the network data source, and your local has to catch up. Now, there's a couple of ways you can do this. Common way of doing this is a full-based approach. So imagine you have a device, you have a network data source. The user opens the app on screen A. When they're on screen A, you make an API call to fetch all the information required for screen A. Cool. That's all you do. You don't do anything more than that. If it goes to screen B, you do the same thing. Fetch all the data for screen B. Don't do anything more than that. And then on another device, on device B, to start off, they go to screen B, make a call for screen B, to do the thing for screen C, do the same thing for screen B. In other words, you only fetch the data that the user sees. If the user never navigates to the screen that requires that data, there's no need to fetch it. And that's pretty much what that's summarizing. Now, this has a couple of advantages. This is very common to implement. Just make it very requires what you screen as you get there. And more importantly, unneeded data is never fetched, right? If the user doesn't see it, no one's there. It's a good thing. But there's a bit of a mysterious drawback here. It's that, well, what happens if you go to screen A, fetch data for screen A, go to screen B, come back to screen A, and then you fetch the same data you fetch for screen A again, go to screen C, and then you come back to screen A, and then you just keep doing this thing where you just keep fetching data and output the same screen back. And the data hasn't changed. So there's another way you can do this. This is actually what we do in Android. So what you do is you open the app and then you try to set up the baseline. And in this diagram, the local data source is trying to be set up as a replica set for what's on your network. In other words, you launch your app and you just try to fetch as much information as possible to just make sure the local data source has everything that the network data source has. Now, you can't really always do this in practice. Maybe you can do it just with the current user, or you can kind of break this into chunks as makes sense in your app. And now in Android, we don't have that much to do, so this is actually what we do. We try to fetch all the news resources and just make sure the local data sources are a set of network data sources. Then, if there's a change, if someone writes anything to the network will send a notification to the local app. And then when the app receives this notification, they go like, oh, you've changed. What has changed since the last time I talked to you? Since the last time we had liaison, what changed? And then you proactively fetch that data. Now, this is great because the minute you launch your app and there's an internet connection, you fetch as much data. So the app can be offline for a very long period of time. It doesn't matter if the user has never been to that screen. You can navigate to that screen, that data already exists because you've proactively fetched. Minimum data use and hash rates gets very tiny long to try to fetch everything, but after that, if there's no change, you don't fetch anything else. Now, the disadvantage of this is that it requires very I'll do my laptop because it doesn't that. Who else? Oh, right. So this typically requires versioning. Your local data source needs to know what version it has, so you can go to the network and ask them what has changed, and then your network has to support this. In other words, if you're working a separate team to your backend engineers, that has to support this kind of thing. But when you do fetch that data, you kind of also have to update the data. In other words, there might be conflicts. So there's lots of ways of dealing with conflicts. I'm going to be talking about something called abstract ends. This is what we use in Android. It's one of the easier and common ones. It's also what Firebase says. There's a bunch of other ones like conflict free, replicated data types. There's a bunch of theory. It's not fun. But this is one of the easy ones. So imagine you have device A and device B. They're both offline. At this point, they're both synced to the network. It's the same data they have in the local database is exactly because of the network. And then at some point, device A, while offline, writes some data, so it goes from blue to green. Sometime after that, device B writes some data as well, it goes from blue to brown. Now, after a while, both these devices come back online, assuming they come back online at the same time. And then after they do that, there's synchronization. Well, what would you expect to happen at this point? who should have, the book with different data, the book of what's the appropriate response, like, what is the actual source of truth? Well, in last right glance, we're saying, well, because device B wrote data last, it was the most recent, so the most up-to-date data when I wrote it, device B should win because the last right glance. So when you come back on my device A, kind of has to update itself as a match to what device you said. Okay. I don't know if you watch It's Always Sunny in Philadelphia, but there's an episode where Charlie is got like, he has this conspiracy and he's kind of like, it's crazy look in his eye and he's talking about some stuff. That's what I'm about to do. I'm about to be Charlie. Because that's good. I already talked about Mountain Android and this is what our data structure is, but so far, I set up developer relations. Google so far just showing you a bunch of pretty diagrams, not much in the way of code. I can chat in, conversating, relay. Let's get into the dev part, right? Let's get into more dev. And now in Android, the very first thing we do when the app starts up is we enqueue. And again, I don't know if you noticed that that's been a theme for both the read and write diagrams. I was talking about queues, I was talking about monitors. The very first time we start up in Android, we enqueue the sync job, work method. Once we get a signal, we'll talk about how to get that signal later. But once we get a signal that's trying to drain the queue, Work Manager will call on our repository and say, like, hey, you should go save your data, go like sort yourself out, get up to date. The repository will reach out to the network data source. The network data source will do so it's all you make your API network request, you try to make your exponential backup, all the things I said. Once it does that, it will write it back to the local data source. Once we write it back to the local data source, because the repository exposes everything with the flow, the rest of the app gets updated. Cool. The same thing happens for our writes. We use suspend functions to write. The repository writes it either to SQL or to the data store, does the liaisons, and then after which the data is exposed to streams and everything goes out. Alright, this is the part I was really excited for. Congratulations, all of you have been suckered into a talk about Work Manager. But more importantly, it's that Work Manager is actually great for all the things that I was talking about, because you can actually use Work Manager as a queue, using it now in Android to defer needs until the network is available. That Work Manager can also be used as a network connectivity monitor, and that is our signal. Right? You monitor the networks, you know that you're online, and then you actually use that as a signal to direct the queue. How do we actually do this? Well, Work Manager works great inside of another X library called Android X Startup. That's how we actually do all this startup. So at Startup, we have a sync initializer. We grab a Work Manager instance, and then that's the keyword, isn't it? We enqueue unique work with the sync work name to perform the startup sync work. Now, what is startup sync work? I hear you wondering. I'll tell you. Startup sync work is a one-time work request. Because we want to do this when we start up. We give it a bunch of constraints. But notice that I give it the sync work constraint. The sync work constraint really is just set required network type. So in other words, we will not work at sync job until the app is connected. So just like that, the few simple APIs are implemented in basic queue and a network monitor. Now, when this queue is actually trained and the work is actually run, this is what our worker in Android looks like. So we do a suspend function, do work, and then just delegate. The worker just delegates to all the repositories. If your topic repository, your author repository, your niche repository, you just sync everything in parallel. It's like go get all your data, do it now. And then if we sync successfully, then we're done. If we don't sync successfully, Work Manager lets it do a result that we try. And the really cool thing about this is Work Manager will try to work with exponential backup. So if you try to say that for whatever reason it fails, Work Manager will be like, okay, you ask it to try, at some point it will keep backing off and it will try to do. So that's three things for free with Work Manager. The network monitor, exponential backup, and queuing. So then again, how do you actually resolve all this in this thing? I was talking about if you're doing this sort of thing where you try to create a back to set. one of the annoying things you have to do some version, you have to do some bookkeeping, right? So this is how we do it now in Android. In our Android, our server uses something I call change list validation. In other words, every model has a version that it's currently at. So when we first launch the app, we ask it, okay, but what version is the app currently at? Well, once we get the topic version, we go to the network and ask the network, hey, give me everything that has changed after this version. In the network response will tell you everything that has changed, and it will tell you the current version the network is at. So once we get the latest version, we update the latest version, so the app is not like, okay, spoken to the network, this is the latest version I'm at. The response also tells us the things that are invalid. If, for example, we publish something, we delete it. And then finally, take all the response from the network, and then we do an observe or a DAO, and then we write everything back in. All right, so hopefully any skepticism about the snippets I showed before about like the read, this is how we do our read, and the read is just pulling from the DAO, and then this is our write is just writing locally. Hopefully any skepticism over that is gone, because this is how we actually complete the loop. We use Work Manager, we use Work Manager to do quite a lot of heavy lifting, and Work Manager eventually will delegate to the repository for parsing, and this is how we kind of handle our conflicts. And that is it. That is one way of doing an offline first app. Strongly encourage you to go check out 900 on GitHub. That is the link for it. There's a bunch of other cool stuff in 900, by the way. If you're looking about, if you care about modularization, just get modularization guidelines that. 900 is also a Compose first app. We've already been saying like Compose is production ready. We're at Compose 1.2 now. You're going to see what Compose will look like, full Compose app, navigation, all that good stuff, and after stop that. And that, with that being said, was open for your questions.
Yes. So, maybe I was under the wrong impression that Work Manager was for example, analytics or something like that, and it would be done right away. Are you suggesting that for one-time requests to update the content of the page, or let's say populate the content of the page, Work Manager would be a sound option?
Oh no, so that's not what I'm saying. Because you're right. Work Manager, like you can check the docs to the headline for Work Manager. It's Work Manager is for consistent preferred work.
Okay.
What I'm saying is this is an offline first app. We're using Work Manager to know what synchronization is the it's the deferred work, right? We have so initially when the app startup, we use Work Manager to fetch as much as to create that baseline, and then periodically we have sync jobs running to say like, hey, it's time to update it. So even though I said like, this is what I'm going to do, it doesn't mean it's only going to do it. For example, if I was giving Twitter, for example, Twitter has an endless newsfeed. I am not going to try to like fetch the tweets of everybody you could possibly see and use Work Manager to fetch all of that. I could use it to like kind of like manage like the user's profile photo or some other thing that can change from device to device, for example. If I change my profile photo on this device, I could, call something change in server. When I pick up my tablet or something, when it wakes up, like, oh, I'm just gonna like update the profile photo because you literally just did that. So again, Work Manager is, recommendation for persistent preferred work. In which case, non-Android synchronizing is an example of persistent preferred work.
That makes sense. You can set the policy as like immediate or something like that.
Yeah.
Right? So if it's for deferred work, you think of a use case in which you want to do it immediately? Or am I misinterpreting what immediate actually means?
No, I don't think you're not. So you just go back and go to.
Because you can set your policy.
Yes, so when we do this, we give, at least we're saying it as one time, but we run this as expedited because we want to do this as soon as the app starts. For example, the fun experiment to do with Android is that, so you can put your phone in airplane mode, so you try to go to Android, and then, it's an airplane mode, and it's not going to share anything. Now you put on your application shade, and you set it off, you put it back on your online, and within a matter of seconds, it will just fetch that data and you see it pop up. In that case, you do want to set it expedited, right? Because one of the technical requirements requirements for the product manager set and manager is that I just want people to be able to open and see that. So in our case, it had to be expedited, but it really depends on your PM says, product and stuff. Yeah. You have a question? But
So you say it's offline first. The first thing you do is fetch data. Do you do any like seeding database, like that you have it even if you were completely offline?
Yeah.
You somehow have the app installed. There's this initial set data there.
we actually went back and forth with this with the team. So the app is designed to be an offline first app, but doesn't mean you will never, you do need some internet connections to catch it. We can't really receive any data that's like this data is always there, because if we did that, then what if we didn't want any of that data anymore? Like what we wanted to be it. So the app, when we say offline first, we mean like for every decision we make, offline, your app being offline is one of the first considerations we make, but we're not saying it's an offline only app, right? It's just first, we take it as consideration. So the minute you do your first thing and you go offline, the app will work. You do the app first thing.
To add to that, so can you first give back the local data, the network call, and then do like Instagram does, like, hey, there's some more new stuff. You want to see the updated version of the data? Is that an approach you consider?
Yeah, I think the only thing that I was kind of like I wouldn't want to change my mind on is that you should always like read from the local database first. So in your case, you're saying like, okay, you read from the local database, and then you're saying like, there's more updates. Do you want to fetch it? How the app knows about that update and stuff? If it's
No, sorry. I meant we show the data right away.
Yeah.
Do a network call in the background.
Yeah.
And then if we see in the response the data has changed, then we tell them that hey, there is more data. Just click the button, we will refresh the sample.
Yeah, I think that's fine. That's perfectly fine. As long as the other thing I'm particular about is just make sure you read from the local database first, and then when you do the network request and you're asking the data, like have written that right from the network request, network data source to the local data source. Don't try to like pull from the network and try to funnel directly from the network to your UI. Then you'll have like conflicting sources of truth. It should be like a single source of truth. Let that be your local database. So right from the network to your database to the rest of the app. Don't try to bypass the local database.
Like when you read from the network, write the database, then deploy.
Yes.
Otherwise, you get conflict if you write directly.
I think the thing is, so let's say you were reading from your local database first, and your local database says, this person has this profile photo, and then you read from your network, and the network says this person's profile photo has changed. Now your local database and your network is saying two different things. So if you leave that screen and you come back, if you read from your local again, you're going to see the initial profile photo that is kind of like out of date. That's kind of like a weird experience. So just for consistency, just network, local, app. Yeah. Oh.
So let's say the product comes back and says, wait, writing to database is too slow. Can we just do it in parallel to feeding the data directly from network to UI?
Also,
parallel. Well, I personally worked on the TBD guide screen where we had like 10 requests at the same time. So everyone writing to database would add up to a couple of seconds before we show the data on the screen, and the user is clicking the button, he wants to see what's slide right now.
yeah.
So
In that case, I'll say do what your PM says, because I've tried to face a wrath of a PM before. They will always win. It's not about every time. If your PM says, hey, I want this data right now, and the best way you can do it is to bypass the database, then I guess you gotta do what you gotta do.
the database. So
Yeah, I guess
is there any suggestion here, like how to parallelize or this?
I would think the issue at that point then it might be the how to read from the database is done. I think like with most of the databases that we have nowadays, it should be quick enough. Like I know Dropbox, well it's not Dropbox anymore, but there's an API called Store, a library called Store that kind of like wraps this for you. Last time I checked, that was quick enough. In 900, we just use it for room, which should be quick enough. I don't know of any strategies because if a PM was forcing me to do that, I like to argue. I'll argue. I'll lose because it's the PM, but but yeah, I don't know. I guess. See, there's probably a couple of others. So like in that method, I'll show you like for the right when we delegate, so we do it in parallel, right? So we make the network, so we do async, talk at the same, call the same, use resource sync, we do everything in parallel. It's just sequentially. We can try to get that code to you, get shot. But ultimately, what the PM says, what the PM says goes. Any other question?
Yeah, so as far as like the exponential backup.
Yeah.
Does it ever give up? If I just say I've been waiting for how long I've read so many times I give up. And once it gets the order of like we're trying to cover a couple of minutes or whatever,
Yeah.
you get the network with it. Oh, by the way, you got networking, I'm just saying.
So in our case, we will just keep backing up indefinitely. We don't have an exit permission for our own failure to sync. Like, we could easily put one in, so wherever it's at. I remember what it did. But we don't currently have an exit permission. We actually tried to discuss, we discussed this on the team, and like the kind of data that we're collecting with all the maybe the BCP, that maybe we didn't really have a need for an exit permission, but it's sometimes just worth us to do the short circuit. But you want to do it like right here. So it can be synced effectively.